Hi, everybody. Sorry I can't be there in person, and sorry for the little hiccup there getting started. But my name is David Churchill, and I'm going to be giving the talk I give every year at AIIDE, which is the results of the StarCraft AI competition. So I'm up here in St. John's, Newfoundland, and again, sorry I couldn't be there. I love being there in person, but I just couldn't make it happen this year. But today, this is the 15th running of the AIIDE StarCraft AI competition, and I think this is the longest running, at least video game AI competition in the world. I know that there are game AI competitions like checkers and chess and stuff that have been running for longer, but I think this is the longest video game AI one. If you want to follow along with any of these results or get any of the data, I'm going to provide the PDF of these slides at this URL, specifically the bottom one here, which is the results for this year's competition if you want to get all that data for nice machine or reinforcement learning purposes. So the tournament format this year was the full game of StarCraft Brood War. So anyone not familiar, StarCraft is this game from 1999 that's still being played by a lot of professional players and AI enthusiasts. And we have a round-robin format for this tournament. So different AI competitions have different formats for who gets decided to be the winner, etc. But in this tournament, we want sort of the most statistically significant result. And so we rank the bots by the final win percentage. And so we have 10 maps that each bot plays a round-robin on, and then they go to the next map and the next map, and then once all the maps are completed, they just keep going and going for however long that we want to run the tournament for. So the game rules that we play with a 60-minute game time limit. So oftentimes bots are not programmed perfectly and they may get stuck in some locations. So we limit it each game to a real-world hour, and then we tie break that with the in-game score if that hour was reached. We don't allow any cheating or in-game glitches, so when you can press buttons infinitely fast, it turns out you can do a lot of interesting things with game engines, so if anyone spots any shady business on the replays later, we will disqualify those bots. Also, this is a real-time strategy game AI competition, and so we penalize bots for slow computation, so we have a little timer in our injected DLL module that times how long bots are taking to compute their stuff. And we also allow for file input and output, so you can actually learn about your opponents as the game goes on. And so in the game, you can actually see the opponent name, and so you can say, hey, if DaveBot constructed these units against me in the last game, well, I'll be ready for him this time in this game. So you can do lots of interesting stuff with the file I/O. A question we used to get a lot of was, why not StarCraft 2? And it's kind of funny now, so many years later, because it's like, why aren't you playing this 16-year-old game instead of this 26-year-old game? So the real reason we don't play StarCraft 2 is because there are other tournaments for StarCraft 2, and I don't want to run them all, and so I let the StarCraft 2 people handle that. But there are new machine learning packages for StarCraft 2 and Brood War that you can use to do all sorts of research if you are interested in using either game. All that is available now. So this year we had 8 new entries to the competition, which is pretty good. So the state of the competition for the last few years has been that we get approximately 6 to 8 of the usual suspects every year who make these incremental changes to their bots, and then we get 1 or 2 new entries into the competition every year as well. Also down here you see this 2023 returning. That means that, for example, my bot, UAlbertaBot, that I wrote and last updated in 2017, I resubmit this every year to the competition, even though it never wins, because it's sort of a benchmark. And so it's nice to, submit a few bots from previous years to see how the better bots will perform against them, so we can sort of track improvement over time. Some nerdy statistics about the tournament this year. So we upgraded last year to play on physical machines instead of virtual machines. I have a few statistics about that I'll get to later. The tournament ran for about 9 days, and the way that I decide how long the tournament runs, it's like at least 1 week, at most 2 weeks, and if in between 1 and 2 weeks, we see that the results have pretty much converged and they're not going to change, then I just stop the tournament after some round number of games have been played. So we played about 18,000 games in total in those 9 days. And so the games are played 8 machines, 1 bot per machine, which means 4 games in parallel. And they're played as fast as the bots can run. So we don't have this human time restriction on the bots. They're playing in superhuman speed. So that's about 3,600 games per bot, 400 bot games per 400 games per bot pairing, and that means 40 games per pairing per map. And so we end up with what I would call some statistically significant data about which bots are better than other bots. And if you are interested in data, I have about 40 gigabytes of StarCraft replay data that was generated during this tournament, as well as all the other data that's generated from all the previous tournaments. So what sort of data is available? Lots of different things. You can find this on the website. We have like the different input-output folders, so what each bot learned over time, all of the bots and their source code, so the competition is completely open source, all the replays, the map filed, all the detailed results, etc. So someone earlier was asking me about how the competition is run. So I have this little shelf here in my rack in my garage that has these 8 Dell Optiplex machines, and I think it's like a i5 10th gen processor or something like that. So we actually have 8 physical machines with 1 bot per machine, and then 1 machine over here acting as a server for those bots, for those machines. We have some software that I wrote 12 years ago and somehow still runs. I don't know if anyone else has software that they're very surprised still runs, but it ran the competition just fine this year. So running the competition is a surprisingly little amount of work now that the software is in a pretty stable state, other than one hiccup, which I'll mention later. I like to include this slide. It hasn't been updated in a few years because there hasn't been a lot of new bots, but this is just sort of a screenshot of like the family tree of the AIIDE bots that have been submitted. And so this is just sort of proof that, you know, open source works. People take earlier bots and build on those. So like one of the bots that we wrote back in University of Alberta was taken and then updated. And so Steamhammer was based on that. And then another bot was based on that. And another bot is based on that. And so we have a lot of bots that have this really cool pedigree that we can trace back almost 20 years now, which is kind of crazy. So I'll hop into some of the results from this year's competition. Here, just so you know, the competitors for the competition, there's no spoilers or exciting announcement here. The results have been available for nearly a month for the competitors, so I let them see the results in real time because they always like trash talking each other as the games are going on. So here is a view of the win percentage over time over the 9 days and 400 rounds of the competition, and you can see here that the results have they're pretty stable. Like no one's going to overtake anyone else, with the exception of 4th and 5th place, which I will talk about once I get to their particular results. One of the other results that's really interesting about a StarCraft AI competition is sometimes these real-time strategy games, or they call them 4X strategy games, you get this sort of rock, paper, scissors effect, where strategy A beats strategy B, but B beats C, but C beats A. And so it's kind of like saying, you know, you run a rock, paper, scissors competition, and rock is the best, right? It doesn't really make a lot of sense. And so it can happen in some of these competitions where you get one bot that does like a rushing type of strategy, and if you rush and your opponent goes for an economy strategy, then you're probably going to win. Similarly, if you chose to defend and they chose to expand or do an economy build, then they're probably going to win. And if you choose to defend and your opponent chooses to rush, then this is the best case scenario for you, and you'll probably win that game. And so sometimes we do get these results. One of the more interesting ones was actually in 2017, where when I say greater than here, I mean that the bot that came in first place had a greater than 50% win rate against the bot that came in second place, which had a greater than 50% win rate against the 10th place. And it turned out the top 10 bots actually had this like chain of beating each other. So that was super interesting. And that really hasn't happened since, and I don't know why it happened then. But the only sort of, I guess, weird result in this year's competition was that 5th place slightly beat 3rd place. Other than that, every bot sort of was in their place. And so the results from this year's competition are definitely, like, the rankings are pretty significant, in my opinion. So without further ado, we have the actual results of the competition. I'm not going to show every single result in detail, but I just like to list the top 5. And as I sort of alluded to before, I guess the most interesting result from this year's competition, not to take anything away from the winner, was that we had our first ever statistical tie in the history of the competition. So you can see over here the total number of games played for these two bots. One had 2 more wins than the other, one had 1 more loss than the other. And so it was a 0.04% win rate difference. And early on in the competition, in the first 2 days, there was a little error on my part. I didn't realize that a Windows update, of course it's always Windows update, right? It had triggered a reset of the sleep settings on the machine. And so if no input had been given into the machine by a physical mouse or keyboard, in 30 minutes, the machine went to sleep. And so I lost about probably between 10 and 20 game results because of that. And one game here or there would have swung these results. And so I just said, okay, this is actually within the margin of error for the tournament. And if you look at this, these two bots, it was really interesting. One bot sort of lost more over time, and the other bot sort of won more over time. And then right at the end, they were just trading places here. And I know you could say, why didn't you run it for a whole another week just to see if these two bots, converge to an actual significant result? But I talked to the 2 authors of the bots, and they were happy to sort of take the draw and become a part of the history of the competition with the first ever draw. So 4th and 5th place go to Microwave and McRave. So Microwave came 6th place last year's competition, so they improved their results. I say 4th and 5th here, but really this is 4th and 4th, I guess, or 5th and 5th, however you want to look at it. And McRave also came, so very similar results for these 2 bots last year. In 3rd place, we had Stardust with a win rate of 74.2%. Last year, this bot came in 2nd place, so they dropped down because PurpleWave did much better this year than they did in last year's competition. I say much better, okay, they went from 3rd to 2nd, but the overall winning percentage went up, so there were some improvements in that bot. And the winner of this year's competition, winning this year's competition as they did in the previous year, was the bot Bananabrain with basically 88% winning rate. I will mention that the winning rates from this year's competition are a little bit arbitrarily inflated this year as opposed to last year because we had one newer entry to the competition that had a few bugs in it, and I asked them, hey, you're really not winning many games. Do you want to withdraw from the competition? They said, no, just keep us in. And so basically almost everyone won all their games against that bot. So maybe 6 or 7 win percent to each of the bots. All the rankings are the same, but the winning percentages are up because of that. So I'll go into just a few details about the 1st and 2nd place bots to give you an idea of what sort of quote-unquote AI is being used in the competition. So the author, Johan, won again this year with his bot Bananabrain. He is a software engineer, and he has worked on Bananabrain, he said, for about 6 total years development time and about 38,000 lines of code, written from scratch and inspired by some other bots. Written in C++, and if you want to know more about this bot and get the source code, you can visit the Wikipedia page for that bot. And again, a lot of people may not realize how much work it is to make a StarCraft bot, and so you see here, tens of thousands of lines of code. Why don't we get more people entering every year? Well, there's a combination of factors, in my opinion. I have some comments on that later, but it's just a lot of work, right? So props to the people who keep entering because of it's more of a software engineering problem than it is a game AI problem sometimes. So Bananabrain plays the Protoss race in the game. So if you're not familiar with StarCraft, you can either play as the Terran, sort of a human race, the Protoss aliens or the Zerg aliens, or you can choose to be random. And if you choose to be random, then the game will decide which race to play for you. And each of those races has sort of strengths and weaknesses within the game. And so Bananabrain chose Protoss. And he said, I've been playing Protoss for a long time, and it was always my favorite race. Also, when I started development, Protoss was the least represented under the top bots, but that is no longer the case. Protoss is actually the most represented if we go back. This yellow color here means that the top 3 bots were all Protoss, and then 4th and 5th were actually playing the Zerg race this year. So Bananabrain includes a variety of strategies ranging from aggressive to defensive or greedy. I chose to do this in order to have a higher chance of having a strategy that is capable of beating a particular opponent. And some of the specific AI things that are happening within Bananabrain, it uses JPS for some pathfinding, so jump point search. It finds paths for retreating using this search algorithm. It uses a combination of A* and potential fields for positioning during combat, and it does use some learning from its file input and output between rounds. And it also uses this Brood War Easy Map library for map analysis. So there are lots of libraries out there if you're thinking of entering the competition, of starting a bot. There are all sorts of tools out there like BWEM, because who wants to write a Voronoi code for the 10th time in their life, right? So all that is available for you. Also, some notes about PurpleWave, written by Dan Gant. So he's a software engineer from the US, and again, about 7 years total development time, 44,000 lines of code, written from scratch. And Dan's a bit famous for sticking with Scala as his programming language. And so the funny thing is, he told me that he chose Scala because he thought it was a more expressive programming language that could write better bots in fewer lines of code, but he actually has more lines of code than the winning bot. So that's kind of a running joke in the community. And if you want to see the source code for PurpleWave, you can feel free to visit the GitHub or look at the tournament page to download that source code. Just some quotes from Dan on the bot. So plays the Protoss race as well. At first, I only set out to make the first bot do a proxy gateway rush, and it grew from there. PurpleWave reproduces human approaches to StarCraft with a bend towards the things bots do better. It recognizes 75 plus strategies and abuses that knowledge to gain economic advantages, defend against pressure, or punish greedy play. So it will try and recognize the opponent's strategy and do something based on that, whatever it has in its knowledge base. It has threat-aware A* pathfinding. A*, of course, everyone knows that algorithm, very popular for game pathfinding. It simulates the economy to optimize production, simulates combat to decide fight or flight. So when it sees, okay, I'm about to enter into this combat, it will actually run a simulation, as some other bots do. It learns the best strategy combinations for each opponent, so it uses its input-output after each round of play to do that. And it takes extreme strategy gambles against predictable opponents. So one of the things that's still active in our competition is that you sort of know, okay, these are the people that are going to be playing. So for example, let me just go to the next slide. Everyone knew the names of the bots and what they would be named in the game at the start of the competition. So for example, they might know, okay, UAlbertaBot is being entered again. Dave hasn't updated the bot in a few years, so let me go back and see what happened last year and try and play against it. So these are the overall results from the competition, and despite my bot not having been updated in 7 years, it still wins 35% of the time. One of the main reasons that we keep re-entering this bot as a benchmark is because it does play random, meaning that so when you play StarCraft, if you start the game, you get to choose which race you want to play. And so at the start of the game, if UAlbertaBot is playing against Bananabrain, for example, UAlbertaBot gets to see Bananabrain chose Protoss, but Bananabrain would only see UAlbertaBot chose random. And then when the game starts, the game randomly assigns one of the 3 races to the bot. And so, in my opinion, more bots should probably be playing random because it has a strategic advantage because you don't know what sorts of units your opponents can have until you've actually scouted them in the game. You can also see some of the artifacts of software engineering here. Some of the bots still crash a few times or time out, etc. So, you know, it's a very mature scene at this point, but the software engineering is still an issue. This is just a bot win cross table here where you can see that really only 2 bots had any sort of upset where InsanityBot was able to win most games against UAlbertaBot, and McRave in 5th place was able to win against Stardust in 3rd place. So not a whole lot of surprises, as I mentioned before. I just wanted to mention the UAlbertaBot Benchmark. So it was last updated in 2017. I've actually mentioned all this already, so I'll just skip right to some results. So the idea here being these are the results for this bot over the past 5 or 6 years. And, ideally what we would see is that this winning percentage goes down over time because bots are getting better. But we see that the winning percentage kind of goes up and down, and so I guess maybe no one has figured it out, or maybe random is just a good thing to do and people get surprised by it, etc. And with the artificially inflated win rate this year from that one bot that didn't win many games, it's probably about the same as last year. Another kind of interesting result is we see here last year, so in previous years we were using virtual machines to run the competition, and I switched to running on just hardware, like just a one machine with Windows installed, no virtual machines. And we actually saw about a 2x speed up in the times that the bots played the game. So this column here is if we slowed the game down to what humans actually play, this is the amount of time that the bot would take. But looking at the wall clock, the bot actually took about 2 minutes. So we're playing about 5 times human speed. So if you ever run an AI competition and you're running on virtual machines, maybe you should consider moving to real hardware. Some frequently asked questions I always get: how long until we beat the best humans? Like I said 5 years, 15 years ago, I have no idea. I'll talk a bit about Google in a second. I know you're all thinking that. What is the current best bot skill level, at least for the Brood War StarCraft 1 bots? I asked some people today. They think it's about a high C level IC Cup rating. Or maybe more accurately, if you look at Brood War on the BattleNet ladder and the average player having an ELO of about 1,500, they think the best bots are around 1,800. So, better than average players, probably, high-level amateur type stuff. Computers can cheat and click really fast, yeah, but we still lose, so I still don't really care about that problem. And all the best bots sort of have these rule-based rules. Yeah, well, go try and write one that isn't rule-based, and you'll see how hard it is to actually do that. And what about AlphaStar, right? Google DeepMind spent, $100 million, don't quote me on that, building a StarCraft bot. If we consider that the year that they built that, they lost more money than our entire university's budget, it's kind of hard to keep up at that scale of deep learning, right? And I'm sure more modern approaches wouldn't cost that amount, but not everything has to be deep learning. Hopefully some of the talks there this year said stuff along that line. So not everything has to be deep learning. For game AI, it's okay to do rule-based every now and then. So what is the current state of StarCraft, or at least RTS game research? I think it's sort of dying off. There's not as many people left doing it as there was in the past. I guess that's sort of all research tends towards that as time goes on, I guess, except neural networks. I think that AlphaStar really scared a bunch of people away several years ago. Google convinced the world that the problem was solved when it absolutely was not. They never had their sort of AlphaGo beat the world champion moment or documentary. And did they suddenly stop working on it? I don't know. We just stopped hearing about it after a while. Maybe, I think that because of this, they had done their public relations job of convincing the world that StarCraft was solved, even though it wasn't. And so I think they got their money's worth out of that. Maybe. It's all speculation. Lots of interesting problems still remain in the domain, especially if you're talking about non-deep learning, search algorithms, this sort of thing, which I'm really interested in. And just to give a quick shout out before the questions, there is a ladder called the Schnail, which is StarCraft and Human AI ladder. It's at schnail.com. They have software so that if you're like, hey, I want to play against these bots, what's the easiest way to do that? It is to use Schnail. You can just boot it up and play against some of the higher ranked bots. They have a ladder with an ELO, so they keep track of these things. Lots of replays and videos of human versus AI. And if you know anything about StarCraft, you know who Artosis is. And there's this 2.5 hour long YouTube video where Artosis plays against some of the best Brood War bots over the last few years. So if you have any questions about human versus AI, I would recommend going there or joining the Discord server, because there's lots of all the people who are still in the scene are on the Discord server. We'll just put it that way. And thank you very much. I'd be happy to answer any questions. And if you want to learn more, there's all my information.
It seemed like maybe playing random might have some kind of advantage, even though a lot of the the AI, the agents, the players pick one of the Protoss basically. I was curious if you've asked them or if they thought about like how specialized are their their approaches to like one particular like Protoss, and what do you think, like how much work would it be for them to basically be able to like adjust their approaches to play random, or are they like extremely specialized to say Protoss or Zerg or Terran, and it would just be basically starting from scratch to play random or another one?
Yeah, that's a good question. I think that again, it's hard for me to speculate, but having programmed the only random bot, I can tell you that after the software engineering problem of like actually getting a bot up and running and implementing all the things like, how do I attack, how do I build something, etc., which is a lot of work, I would say that it would take approximately, like whatever amount of time it took you to put in, let's say, your Protoss strategy, so whatever code you use to do the Protoss strategy, it'd just be basically triple the work to do the other two, because the strategies, like all the races in the game have completely different units, they cost different amounts, and so it would be approximately triple the amount of time that you took putting in that strategy. Now, maybe not triple, maybe double, something like that, but certainly a non-trivial amount of work.
I had a quick follow-up question.
Oh yeah, sure.
Yeah, just a quick follow-up question. Has anyone considered like a portfolio kind of player where they just take the three best, one of each, Protoss, Zerg, or Terran, and pick, when they see which one they got assigned, use that one?
Yeah, we actually had a bot that did that in the past. So in sort of two ways. Once we used to have a competition way back where we actually opened up the whole map, and so you could see everything. And one of the bots was just called Mimic Bot, and it did whatever the opponent was doing. And that was kind of funny. Like, who wins in that situation, right? It just saw the action of the opponent and did it immediately. But another bot did use a portfolio approach where it took like the best 6 bots and like chose randomly from them. And I cannot remember the details of that. Someone has done it, and the only reason why people, I guess, don't do it now is because it's kind of hard to like take this 40,000 lines of code and that 30,000 lines of code and like make one bot out of it. It's not really trivial, but I would encourage people who have, a really good bot in one, like say Protoss, for example, whip something up for Zerg and Terran and just try it out. And I think you would just get a higher win rate because of the tangible advantage that you would have by the opponent not knowing what you are at the start of the game.
Yeah, thanks for hosting this great competition. So one thing that I'm wondering is whether people looked into this information qualitatively. So like, how did this bot win? How did this bot lose? So like I was kind of remembering back some similar experience where I was thinking about like playing like Japanese mahjong, where they have a similar rating system, and we see 1,800 people playing by the book, and like 2,300 people, they read very deep, they play unexpectedly, and then sometimes like 1,300 people below average beat them because they play very randomly, erratically, and there are some luck elements in that game that even top level players get astonished. So like I wonder whether maybe also for the whole room, what would happen? How would you think? What was the insight that you think that would be useful if we look deeper into deeper beyond the win rate statistics?
Yeah, that's a good question. I think that in StarCraft that there are so many different strategies that you can implement that are all surprisingly good, right? So there might be 30 or 40 strategies that professional players use. Maybe there's more, but some large number. And so there's kind of two general ways of approaching a bot strategy. One is sort of, I'm going to play sort of a standard opening, like predictable but strong, and then based on what I see from my opponent, I'm going to adapt that somehow. And then the second way that people do it is say, I'm going to put in 20 different strategies and just learn which to pick the next round based on how that last one I chose against you this round. And so, you know, which you choose is up to you, and also it depends on the tournament format as well, because we're playing 10,000 games, so you can afford to lose 100 games and learn over time. But if this was like a double elimination tournament, that would you certainly wouldn't want to pick a random strategy from one of 20, right? So the reason why people lose is either A, because they chose the wrong strategy, or someone had learned against them, etc. But basically the development cycle of a bot is to like take all of your StarCraft knowledge, put it into this sort of rule-based system, implement a bunch of AI solutions to accomplish the rules that you want to play, and then you play a bunch of games against other bots, you see where you're weak, and then however much time you spend, you try and fix that weakness. Like, I lost to that rush. I've got to identify when there's some units in my base and do this. Now I lost to that sort of strategy. Now I have to put in a little thing here. Because if you're not Google, like, machine learning the entire game is very difficult, if not impossible for anyone who doesn't have those resources. So you really do have to like take this iterated approach. And generally the reason why people lose is because they weren't strong enough against whatever their opponent chose to do. And I apologize for being so vague, but that it really is what it comes down to, I think.